afternoon, everyone. Being the last speaker within the batch, I have responsibility on my shoulders, which is to make it short and sweet. So, and give you guys back your afternoon. So, with that, let's get into it and talk a bit about how can we solve the conflict between agility and reliability within CI/CD environments. Let's define the problem. We have an inherent conflict between continuous integration, continuous delivery, and our ability to essentially keep our system stable. On one hand, I don't know of any executive at a large or small company who doesn't want to have their entire roadmap delivered yesterday. So some of the challenges that we've talked about today have to do with how do we build the software, how do we prepare the software for actual delivery, with some really great speakers, some really great content. What I want to focus about is really the flip side of this, which is how can we, on one hand, deliver software very rapidly, innovate, please our customers, while on the other hand, keeping it stable. Because we've talked a bit about applications running at scale. If you're using an online banking application, and they just delivered a really cool, hot new feature, but you can't send or receive money, it's really no good. So let's talk a bit about that. Really, what we've seen that if you want to have agility and you want to have scale, and this is what all this event is really about, you have to have the right tools in place. This means high-level languages and new stacks that essentially enable you to achieve all these goals, and ones which are designed for distributed systems, microservices, scale, asynchronicity. Usually the way that I kind of look at the world within this context is really dividing into looking at the things that are kind of disrupting the market, like clusters, containers, and frameworks. Clusters essentially like Elasticsearch and Spark, which really essentially enable us to process data at scale. Containers, new ones, disrupting the market like Netty and Node essentially, which are completely different from what we used to see previously, and are all asynchronous based on messaging at really, really high throughput and scale. And last but not least, are frameworks, which engineers won't need to put in place. Things like Akka and reactive programming, which make the process of delivering software into production much more complicated just because of the sheer complexity of these frameworks. And let's dive in a bit deeper into this. What is essentially the problem that I want to focus on? It's really the problem what we call the hot potato, meaning you want to deliver software very rapidly into production using all these new environments which your engineers want you to use, and those are also the ones which you need to put in place to actually attract top talent. And you want to essentially ship hundreds or thousands of new lines of code into production every day. That, on the other hand, conflicts with your DevOps and Ops personnel, whose job is to maintain uptime and to maintain stability. And they know that with every drop that gets essentially delivered into production, the chances of something break materially, exponentially increase. Nowadays, with microservices and connected systems, some of the stuff that Jacob spoke about, your system may be completely stable, but one of your partners may come in and change their API, change their data stream, essentially, and you're again faced with a situation where your application is broken. So all these modern tools and these technologies and these approaches present from a production standpoint 3 key challenges that we need to overcome in order to fully realize that dream that we have of being much more agile and being able to deliver software more quickly. These are in the space of monitoring, diagnostics, and overhead. Monitoring is essentially how can we put in place tools that enable us to see the signal and separate it from the noise. When we're operating at such scale and we're throwing so much code into the system and relying on all these external systems, being able to detect anomalies, know when things break, and do that not in a reactive manner, essentially where our customer calls, but that we know in advance so we have time to respond, is crucial and is a huge challenge for organizations today. This also is a direct segue into diagnostics. Once you've understood that a problem exists, how can you obtain the actionable information that you need to go in and fix the issue without spending days or hours and days of very expensive, costly engineering time trying to manually resolve those issues. We have customers, waiting on the other line. And then the third bit is how do you do that without introducing material overhead, both in terms of performance, also in terms of manual overhead of people having to deal with all these systems. So these are three big challenges that companies are facing today. And for CI/CD to be reliable, the last bit is we must make sure we have actual insight and communication between DevOps and engineers. And let's dive into that, because really, the speed of delivery, the speed by which you're able to ship new software into your customers is equal to the speed of response. If you cannot respond quickly when things break, be it like rolling back, just identifying, oh, if this is what's happening, and make a quick decision, you want to roll back or want to continue forward. And being able to essentially come in and proactively fix the problem, you cannot deliver rapidly. And really, what we see in terms of the solution is a really threefold strategy, which is first, and it's so crucial, is you have to build monitoring and debugging into the stack. It's almost like security. You don't build your application and then you slap on security at the last minute. That will not scale. It will get poor to medium results at best. Second, you want to have tools that scale with your application, meaning you're running all these hybrid environments, okay, and you're constantly adding and provisioning more instances, more computing power into your cluster. So you must make sure that whatever you introduce as a solution scales well. So you don't end up, well, we were able to log the system very well when we had like 20 nodes, but now 200 nodes and a bunch of other new technologies were kind of lost. And the third bit is really how do you build and bake communications between dev and ops into the process? How can you make it so that when ops figure out something's amiss, something's wrong, they can communicate actionable information to engineers in the way in which engineers want to see that information come through the pipeline, be it through Slack and be it through Jira. But how can you communicate that information efficiently so you don't end up with, again, a hot potato game of back and forth over email for 2 days to essentially have somebody come and say, all right, I'm going to take charge on this. And really, our approach to this, both when we work with our customers and talk about best practices, but also as a vendor who build tools, is against a threefold strategy, which is, first of all, how can you build technologies, and this is the business that we're in, this really can proactively tell you when code breaks, even across hundreds of millions, and we have customers processing billions of requests. How can you know in production when you deployed something very rapidly, you just, a new patch or your weekly or your daily drop, how can you immediately know when something broke versus waiting for your customers to call you? And then another thing is, how can you get analytics, essentially, that will help you prioritize and cut through, again, the noise and get to the signal. Focus on the issues which you want to fix today, fix next week, or not focus at all. And there's so many tools and there's so many technologies in this space right now that are coming in. So this is an interesting problem, and one which, of course, we work on, especially with our customers. I would love to talk to you more about. And the last bit is really, we built integrations between all these tools. So how can we make it so that if something breaks, for example, and ops figure it out, they can with one click open up for, say, a Jira ticket. An engineer gets the ticket and sees all the actionable information, the source, the code, the variable state that they need to do, they need essentially to come in to fix, so they don't have to dumpster dive and spend all that time. So this is really the business that we're in, and some of the challenges that we see our customers facing nowadays. And I'm more than happy to chat with anyone who's interested later. But with that, all I have to say right now is thank you.